SOMdata, we are a firm based here in Valencia. We are very young, and I'll tell you more about what we do, what the projects we are currently on, and who we are. But first, I want to start by, there's one thing I do want to say. We are a very young company, and I want to highlight that the transition between being an idea and being a full-time job for all the people working in SOMdata was extremely quick. And I wanted to say this because the demand that is out there for the things that we can do or the things that we know how to do is impressive. So from just discussing the idea to having meetings with big companies and signing contracts and having projects, it has been stunningly quick for the three of us with the partners. So yeah, artificial intelligence, right? So when I was invited to give this talk, I of course went to YouTube and searched for many speeches and talks of important people. Andrew Ng, which is a professor at Stanford, and he was the head of Google Brain and the department of IT in Baidu. He founded Coursera and so many great achievements. So he and many others usually start or end their talks with a catchy phrase. And I really liked this one because, of course, he talks about the impact of artificial intelligence, and he compares it with electricity at the time that it was being discovered. Not many people knew the uses that were come out of electricity, and we know that nowadays it's everywhere and everyone can use it without hesitation and need of education or nothing whatsoever. But what he doesn't say, and the thing that I really like on this phrase, is the fact that today on high school, we are taught what electricity is, how does it work, what can we do with it. But the truth is, and I shouldn't be saying this on a school of engineers, but not many people know what really electricity is and how to use it. But everyone uses it, right? And I think, and I hope, that in the future, our children will learn in high school how to use artificial intelligence and how to code something to make a product or applications or anything. But I'm sure that not everyone will know what artificial intelligence is, and not everyone know what it is today. But everyone will use it and is using it right now without any problem. We just have applications on our cell phone that have artificial intelligence. And yeah, that's the idea, right? So if you ask anyone, any CEO or CTO of a big firm, or even not so big, they are all using it, right? They want to be cool and they want to be in the hype of saying that they use artificial intelligence, machine learning, big data, data science, anything. And that's okay. They are not hurting anyone but themselves by saying that they are, but they are not. So if they are not, their competitors are using it. If they are not, they will be using it soon. And if they are not going to use it soon, then someone will use it, go to the market, and kick them out of the market, right? So I'm an economist by my background, and in the career, they taught us about the entry barriers of a market, and I wanted to highlight two barriers. A typical one is the expert knowledge. This is the experience that you gain from being in a market and being in a fair position in that market, and all the experience that you acquire through your time that teaches you to do things better, more efficient, give a better product. But slowly but surely, this is changing towards a new entry barrier, which is data and AI. Because all the things that you are learning in your market, in your business, all that data could be acquired, it could be collected, and put it into a machine which will do whatever you do faster, efficiently, and better, right? So if you are in a fair position in the market, you should be worrying about acquiring the data so that your competitors don't get ahead of you, right? So the other barrier that I like to put on the highlight is the ownership of resources. On the faculty, the professors give this, the example of owning, for example, oil or iron or any limited resource. And if you own the only resource to make something, then it's very hard to compete with you. But today, of course, data is, we live in an era of internet and data is everywhere. And how can we protect our data, right? Well, the truth is that owning data and owning AI on your market is probably the best way to protect yourself. And I always like to give this example of Blue River Technology. These are two guys in USA that started to take pictures of lettuce sprouts when they were growing. So they went with their phones or a camera taking hundreds of photos. So they could decide whether to kill or not a lettuce sprout, to let it grow or not. And they made a product. They sell it to some farmer and then builds these huge structures with cameras pulled by a tractor, and we're taking photos and photos of sprouts and killing the ones that were not in the right position. Because, well, we have time to explain it. So the thing is, when you plant a plant, you throw seeds to the field, and then they will grow, right? But if they are too close together, you have to remove those that are too close together because they will fight for water or earth or whatever. So what they do is they go through the line of lettuces, and if they are too close, they kill one, and then at the same time they use they spray fertilizer exactly on where the lettuce is. So the example, the idea is that they now have the probably only and best database on photos of lettuces, sprouts, and no one can compete with them. Even, for example, Google, which are very good at making the biggest neural networks and the best algorithms and whatever, they cannot compete with them because they don't have the data necessary to train that model. So they're saying that by using their technology, they are making lettuce fields 10% more productive, which is excellent, right? So back to my business. I want to present to you two use cases that we are currently involved in. And the idea of this is to show that data is not only numbers, it's not only the temperature or the sales or any number, but could also be word, could also be images or anything on the world, right? So first, I'll start with natural language processing, and then the funny part with image processing. So hopefully you all know what NLP is, but I'll give a brief description. In artificial intelligence, there are a few problems which are called AI complete, which are very, very hard things to solve, because you need several methods or techniques to work together and work correctly. In NLP, we need image processing to read a text. We need to understand and generate the text, deal with unexpected situations. If we are talking with a machine, then humans are not fluid speaking normally. So machines expect straight commands and straight sentences, and humans tend to go around and say things that doesn't really matter. Well, machines have to take that into account. And the other things that we need machines to deal with is to be intelligent. For example, bunker problems. Anyone know what bunker problems are? Well, here's an example and a quick test for everyone. We have 6 figures on one side and 6 on the other one, on the other side, and we have to find what is the characteristic of pattern that differentiates both groups. So I'll give you 30 seconds and see if anyone can find the difference. Anyone? Very good. These ones are convex and these ones are concave, right? That is, we can draw a line between 2 points inside the figure and the line crosses the borders of the figure. On those ones, it's impossible to do. So if this kind of problems is hard for humans, how can we expect machines to learn it by themselves? It's a very big trouble. So in the 1950s, the question of can machine think was approached by Alan Turing, very famous guy, and he did many things, but one of the things that he did was to think about this question. He said, well, I don't believe we can solve this issue, because how can we define what intelligence is? Or how can we define what thinking is? Where's the line, right? So he said instead we should focus on the question of how good can computers imitate us? And he established the Turing Test, which I like because he uses natural language process or natural language to define whether a machine is intelligent or not. The test consists on a person, a human, or an evaluator, which has to talk with a computer and a human, which he doesn't know which one is the computer and the human. And the only interaction is by making questions or having a conversation. So at the end, if the evaluator cannot tell the difference between the human and the computer, then the machine is intelligent, right? So if you can tell the difference, it must be intelligent. But when we think of intelligent machines, we think of these kind of things, right? But the truth is that we are not that far away. It's another quick test. We have two texts here. One was written by a computer, and the other one was written by a human. I will give you 30 seconds again, and see. Let's vote on which one is one. Shall we vote? Okay, so the first one. Who thinks the first one was written by a computer? No one? And the second one? Who thinks that the second one was written by a computer? 1, 2, 3. The other guy, we don't have enough evaluators, right? So, well, that's the correct answer. But I don't know if everyone was sure of the answer. And maybe we can say already that machines are intelligent or not. Well, I should define natural language processing a bit more. It's just what we want from computers is to have a conversation with them, to reduce the platforms or the interface to its minimal shape, which is them disappearing, and just speaking with computers. If we are able to do this, then we can ask many things of computers, like summarize a text or a book, give us the meaning of the book, translate things correctly, relay things inside a text, give us what's the relationship between Trump and USA without knowing it, detect entities, which is what I will talk about later, even better, detect emotions or sentiments of what was the person that wrote this text feeling at the time he wrote it. And the pinnacle of NLP is to be able to make that machines detect things that are not in the text. For example, sarcasm, ambiguity, omission. Those are things that we humans are, well, not everyone, but some of us are good at detecting things that are not said, but we meant it, right? So if we can do this, then that will be the solution to NLP, but we're still far away from that. This is a very good example that I really like on what we expect the conversation to be with computers. This guy went to his house and opened his laptop, and he saw that the grandmother was writing in Google, please translate these Roman numbers, MC, blah, 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 to normal numbers. Thank you. So he took a picture, and it went viral, and Google, of course, was laughing and answered the question. So one thing on this picture that makes us think is that it's true when we talk with computers, we tend to change the way we talk. When we all search on Google things, we will reduce our language, we will be very, very concrete. If I were to search this, I would put Roman numbers converter or something like that, right? But what if we could be like that, right? There are many, many examples of this, very funny. So if you look on Wikipedia, what is natural language processing, there is a list of endless topics with their own Wikipedia page, with research and everything. It's endless. And if we have sound, which I don't know, I will all to see where are we right now and what we want NLP to be. And I believe this is a great example. Let's see if.
So let's go back to this example. Let's say you want to ask Google.
OK, 1 second. This is in Google I/O. They were presenting the last Google Assistant on what they are working on. And is Google Assistant making a reservation in a haircut salon.
So let's go back to this example. Let's say you want to ask Google to make you a haircut appointment on Tuesday between 10 and 2. What happens is the Google Assistant makes the call seamlessly in the background for you. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you. Let's listen.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for around? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's your first name? The first name is Lisa? Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day. Bye.
So it's a great example by Google. Of course, they picked the right one. The CEO, Sundar, he tells that they have many calls like this that don't go so well. But yeah, that's what we want, right, in the future. And what is happening underneath all this funny conversation? Of course, the girl on the haircut salon cannot tell the difference, probably, that she wouldn't tell that she was talking with a machine. The problem of speech to text to speech seems to be solved. Text understanding too. Deal with unexpected. We see that the Google Assistant was able to deal with having no time at that reservation time, yeah, and to see how to solve the problem. And all that while being very, very human. In fact, the machine learned to say which doesn't mean anything, but we humans say it, and by itself, she learned to do that. Great, right? So our project right now is based on named entity recognition, which is the idea to find on a text things that are important. For example, the typical things to find are organization, locations, persons, currency, percentage, numbers, etc. And the project that we are working is on patient follow-ups. We are working with a company that manage hospitals and house for old people. And every day the nurse or the doctor will go to visit the patient, and they want now to make it by voice. It's part of the project too. So while the doctor is checking the patient, she will say, well, her pressure, blood pressure is something 80 over something, and the medication that we need to change to something is, I don't know, corticoid with irbazone and 16 milligrams. And yeah, that's the idea. So we have to find these kind of entities, right? Because right now what they have to do is to fill this follow-up and then go to each control. You have to go to diabetes control, you have to go to oxygen control and fill the fields. So they want to do this automatically. We are working on it right now. They want to also, they just told us last week that they want it to work in Catalan too. So yeah, we tell them no in Valencia, but yeah, that's part of the problem. And this is the project that I like the most that we are doing right now. Is based on image processing. We are working with a company that manages water here in Valencia. Well, all over the world, but it's famous here in Valencia. And what they want is to do reports on water, on the quality of water automatically. Right now, well, I'll explain the whole process. To say if the quality of water is good or not, you have to check for protozoas, which are microorganisms. And you have to take a sample of the water and go to the microscope and see what protozoas are in the sample, how many, and if there are colonies or they are alone or whatever. And to do this, they told me about 40 minutes each time, and they have to take like 200 samples each month. So it's a lot of time from people that is highly qualified, because you need to know the difference between the 30 or more protozoas that there are on that water. So of course they want to do this automatically. The first part of the project was to make a web so that people, the experts on the laboratory, could tag the protozoas in the image that they have. They told us thousands of pictures of protozoas. And so we told them, okay, but do you have them tagged? And they said, what was that? Well, we need, of course, to teach an algorithm to tell them, in this picture, only this part is a protozoa, and that protozoa is a collapse, and I don't know anything else. Actually, what they have to do is this, right? To say in this picture, this is what, this is tal, blah, blah, blah. So when we get to, say, 300-400 pictures per protozoa, then we can train a neural net to detect them. Right now we are around 60, 70, and we are starting to train some neural networks to help the people tag the protozoas. It's called active learning. While they are doing this, what we want is that the algorithm to automatically detect a protozoa and recommend the tag. If that's correct, then of course they will say that's correct. But if not, and this is key, they will correct the algorithm, and that's valuable information for the neural net, because they will try to show the pictures where the neural net has doubts, and solving that doubt is an easier way to learn. It's a faster way to learn. We still need hundreds and hundreds of pictures. And what we want at the end is something like this, that you can hear the sound. So we want something like this, but with protozoas. So they can count the protozoas and automatically fill that report. It's still on the work, but we hope that we are able to do it with a good enough precision, which is the problem. So like I said, they waste, or they use, about 70 hours of work each month from expert personnel, which they hope to reduce. There are over 30, not over 20. And yeah, the applications are endless for this kind of machine learning technology. We hope that by making a neural net that is able to detect protozoas, it could be easily applied to other stuff like, say, detect things on the blood or things on other types of water or fluids. Because, I don't know if you know, but if you have a huge neural net that is already trained with some kind of pictures, you have the weights of the neurons, which are able to, they have some learning on how to take apart the picture to find patterns, right? So you can train only the last layer so that they classify, the layer classifies or detects whatever you want. So hopefully that's the future, and we will apply it to many, many more things. So I see that there are some people from economy. When I started the master, I had big problems with coding, because in economy you don't learn how to code. I had to keep up with the pressure, but yeah. So I want to show that we can make use of artificial intelligence and data science without the need of being experts in programming. This is an example, and I want you all to participate. If you have Twitter, please take it out. And I want you to make a tweet saying whether you like or not the summer in Valencia. And I want you all to put this hashtag so we can, in real time, see the tweets, if I can. Oh my God. Don't tweet yet. Okay, now tweet, please. In English, right? Okay, there's mine. So what this is doing is in real time taking all the tweets that have that hashtag, and it's classifying it in the negative, neutral, and positive tweets, right? And what I want to show with this, that is neutral, right? What I want to show with this is that the code behind this application, which is actually just a funny example, is just maybe 10 lines of code that you can get from the internet. And I want to show them. Sadly, we don't have Python here in this computer. Otherwise, there will be some pretty code. But the lines of the code are just these ones and these ones, right? It's so easy, and it's all on the internet. The sentiment analysis is just a library, it's text blob. The gathering of tweets is automatically done by the API of Twitter, and a library in Python, which is called TweetPy, I think. So I wanted to show that you don't have to be afraid to try and do things with data science and machine learning, because it is true that making a convolutional neural network might be difficult. But there are many pre-trained neural nets out there that you can use, for example, to detect people on the video. That neural net is open source. You can use it. You can make an application out of it. And you don't have to pay to anyone. Another example, let me see if... Again. All right, it's over there. 1 second. Or there are more tweets. You can also look, for example, I had another hashtag, because I thought that all the tweets were going to be positive, right? So I had to put something negative. Oh my God. Well, one positive, right? Oh my God, well, good thing. Okay, so another example with, no, or yes? No. Look at this text. It's just, I made it myself. It's just a text of the G7 with the countries all signing, deciding to make a fund with 150 billion of funding, and it was signed by the presidents of those countries. And yeah, it's unstructured data that is easily captured. This example is with R. And we can see here that we just a few lines. We are reading the text, which is a standard R. Here we are using a package, I believe is RVest, which has a pre-trained model on entity recognition. This is structuring the data frame, and we have here what the data frame has found. The countries, the presidents, the money. Here I was missing the billions, but yeah. And with another chunk of code, we can make a pretty cool visualization of the data. So it's pretty quick, and I shouldn't be saying it, but many companies are selling this kind of pre-cooked solutions by a lots of monies, and we can do it ourselves in our home. I'm not saying that you shouldn't hire me, but you should be aware that this kind of troubles or problems can be easily solved. For example, analyzing the impact of a certain campaign in Twitter is just the same that I just did, and you see it every day. And Well, I think, oh my God. That is it. Thank you very much. If you have any question, please